Alright, now that we've gone through the integral rules for basic integrals, we just kind of briefly went over those. It's just finding the antiderivatives, so we're going to go through a few basic examples here. So if we look at example 7, the integral of 4 dx, because it's with respect to x. Alright, the antiderivative of 4 is 4x, and then since it's an indefinite integral, meaning there's no limits of integration, we have to add the plus c, so it's 4x plus c. If we look at example 8, we have the integral of 4x dx. So this is an example where we factor that 4 out in front of the integrand, and it comes into play a little bit later when we simplify. So this is 4 times the integral of x dx over here on the right hand side. So then it becomes 4 times the antiderivative of x is x squared over 2, right? N is 1 in this case, so 1 plus 1 divided by 1 plus 1, and then 4 is divided by 2, so we end up with 2x squared plus c. Now if we take that 2x squared plus c and we take the derivative of it, we end up with 4x. So as we can see, we're going back and forth between derivatives and integrals, so we do that. If we look at our next one down here, we have the integral of 3x dx. Once again, I'm just throwing this in there so we can see that we have to factor that constant out in front. It makes it a little easier for us. So rewrite that integral as 3 times the integrand of x dx here, and we have 3 integral of x dx, the antiderivative of x, it's really like x to the first, right? So x squared over 2. Now the 3 and the 2 don't cancel, so we can write that as 3 halves x squared plus c. Please don't forget the plus c portion on this. If we look at example 10 here, this is where we're going to break that in. That was kind of that f of x plus g of x that we looked at in the last video. Same kind of concept here. We have two different terms now. We have an x and a 2. So we have the integral of x plus 2 dx. So we can write that as two separate integrals. So we can write that as the integral of x dx plus the integral of 2 dx. Do you have to write it this way? No. But for simplicity, for you to understand what's going on, we're going to look at it this way, but later on you should be able to just do this one in your head and kind of see it. But notice that each one has a constant of integration. So the antiderivative of x is x squared divided by 2 plus, we're going to call it constant 1. And then the antiderivative of 2 is 2x plus some other constant 2. Notice since it's two separate integrals, these could be termed two different constants. But since it's a constant and we really don't care about it right now because we don't have initial conditions to solve or satisfy this, we can say that c1 plus c2 is just a constant, because it really is. If it's 2 plus 4, 5 plus 8, all those different things, it really just ends up being a constant. And if we take the derivative of a constant, it's still going to be 0. So we can write the solution to this integral as x squared divided by 2 plus 2x plus c.